This is the second video of the band steering setting for UniFi access point. If you haven't watched the first one, please do, because only in the first video we covered the context of this topic, and in this particular video we are going to focus on the testing only. Before you continue watching, here is a warning. In this video, we will have tons of problems and issues we couldn't find answer. You will see failures after failures. Instead of wasting your time, maybe you want to stop here. This is the test environment. In the lower part of the screen, you can see 3 Mac machines. They have the sniffers open already. In the UniFi network controller, if I go to the SSID setting, as you can see, I enabled all the 3 bands and disabled band steering. If we check the individual access point, go to settings, you can see the band steering is also off. In the middle, you can see the Windows machine, right? I am going to use the Windows to start the testing. You may know for both Apple devices and Android devices, they prefer 5G or 6G Hz already. However, for Windows, if I go to the device management, for the Wi-Fi adapter, go to Advanced, there's a setting called Preferred Band. By default, it's no preference. That's exactly what we want to achieve, because we want to isolate the initiatives from the client device and from the AP. This video is just about the AP setting, so we don't want the client to have preference when it comes to band selection. As you can see now, for the Windows, it has the desired setting. From the UniFi network controller, you can see currently there's no Wi-Fi client connected. Let me start the 3 sniffer instances. Now we are ready to connect the Windows to the SSID. Go to Wi-Fi. So the first one is the one we want to connect to. Click on it. Connect. Okay, you can see from the UniFi network controller, it's connected to 6G. Disconnect. Try again. Yeah, 6G again. Disconnect. Connect. 6G again. What it means. By the way, currently the Windows machine is very close to the AP. Even though we don't have the band preference set, apparently Windows connect to 6G every single time. There must be some algorithm within the Windows Wi-Fi driver. So even though you disabled the band preference, the algorithm still decide the 6G is the choice. Let me stop the sniffers. Let's examine the captured Wi-Fi frames. I opened the 3 captured files for the 3 bands in lower part of the screen. So the first one is for 2.4 GHz. I have already filtered the frames using the MAC address of the Windows machine so that we only see the frames we are interested in. So let's examine starting from this one. What's this? It's probe request. It's sent from the Windows machine. It's a broadcast. Basically, it's asking, okay, for this particular channel in 2.4 GHz, tell me what are the available SSIDs. Then it received a whole bunch of responses, came from different APs. This particular one is from our test environment, and the SSID is the one we are testing with, right? Nothing special. It received response. If you go through all the frames, you won't see any authentication and four-way handshakes because the Windows machine never tried to connect to 2.4 GHz. Okay, then move on to the 5 GHz. The similar situation, Windows machine sent out probe request and received probe response, including this particular SSID for 5 GHz for this channel. Again, nothing's special. And then move on to the 6G. That's the interesting part. As usual, the Windows machine send out probe request, but SSIDs which are not relevant to our testing at all. So for 6 GHz, the Windows machine never received the probe response from the AP, but it decides to start the authentication and successfully complete the 4-way handshake, and it's connected to 6G. That's very interesting. How on earth the Windows machine got the information about the 6 GHz about this particular SSID? The answer is in the probe response in other bands. Let me show you what I mean. For the 2.4 GHz, let's pick this random probe response. As long as it's for this SSID, we are good. Click on it. If I expand the wireless management, expand the tagged parameter, there's a very special section. This one is called reduced neighbor report. It is part of the 802.11k neighborhood report standard. Let's see what it includes. It only includes one neighbor AP information. See what's the AP's channel 213. That's exactly the channel for 6 GHz. And it has the BSSID value for the 6 GHz as well. Just from this section, from 2.4 GHz, the client, the Windows machine, already knew all the information it needed to connect to 6 GHz. Let me explain the background. Before 6 GHz was introduced, for 2.4 GHz and 5 GHz, normally the Wi-Fi client will do the environment scanning and find out the available BSSIDs by itself, which means it will try all the possible channels and get answers by itself. But when 6 GHz was introduced, just to save the client's scanning time, client can utilize the neighborhood report, which is reported in other band, which means the client even never need to scan 6 GHz. It can get the 6 GHz BSSID information from the probe response of other bands. That's how it works, and that's what happened in our testing. In the right part, in the 6 GHz Wi-Fi frames, the Windows machine even never tried to ask for information about this SSID, but it could directly connect to it because it already had the information from other bands neighborhood report. So if we check the 5 GHz probe response, for example this random one, expand to the same section, we have the exact same information. See, this is for the 6 GHz BSSID. Okay, now we understand what really happened in the 6 GHz part. But there's still one thing I cannot answer. The Windows machine throws 6 GHz every single time, even though we didn't set the band preference. I guess that's how modern Windows works, but I'm not 100% sure. If you know the answer, let me know in comment. It's time to enable the band steering setting on AP level. On Windows, you can use a freeware tool called Wi-Fi Info View. It can conveniently show you the selective BSSIDs and their corresponding information, including the RSSI or signal quality and channels. Because I put the Windows machine very close to the AP, the signal strength is very good on all 3 channels. Now let me go to network controller. For this AP, go to settings, enable prefer 5G. Okay, I'm going to start the 3 sniffers. Okay, I'm ready. Go to Windows, Wi-Fi. Click on the SSID on the network controller. Let me display the Wi-Fi client. Connect. Okay, it's connected to 6G again. Disconnect. Connect. 6G last time. 6G one more time. From what we see on the surface, it behaves exactly the same as in our first round of testing. Let's look into the captured Wi-Fi frames to understand what's the difference. Here are the 3 captured Wi-Fi frame files. Surprisingly, we have the exact same situation as before enabling band steering. So as you can see, for 2.4 GHz, we have the probe response, and for 5 GHz, we have the probe response, and for 6 GHz, we don't. Anyways, in 6 GHz, we saw all the successful authentication and 4-way handshakes. Exact same situation. I don't see anything different. I'm confused. To double check, let me change the Wi-Fi client device to, let's say, a Android. Let's see what's the result. On the Android, for the SSID, click connect. Okay, as you can see, it's connected to 6G. Try again. 6G again. If we look into the captured Wi-Fi frames, you see almost the same situation as Windows. For 2.4 GHz, you see the probe response for this SSID, and it does have the reduced neighborhood report. It has the 6G BSSID information. And for 5 GHz, similar situation. It did have probe response. For this SSID, did have all the 6 GHz information. The only interesting new thing for the Android device, see the first packet? It's a probe request. Remember, for Windows, the Windows machine even didn't bother send the probe request, right? But interestingly, implementation is a little bit different between Android and Windows. For Android, it still sent out the probe request, but the UniFi AP didn't respond. Android still continue to connect to the 6G using the neighborhood report it received from the 2.4 GHz and 5 GHz, and the authentication was successful. Still confusing. We didn't see what I expected in the diagram. For all the 3 bands, it worked the same way, just like you didn't change the band steering setting. Let's test it the last time using iPad. On iPad, I already launched the UniFi Wi-Fi Man app. Now it's not connected to Wi-Fi. Okay, connected. See, it's connected to 6 GHz. Disconnect. Connect again. 6 GHz again. Disconnect. Connect. Okay, 6 GHz. So all 3 times, 6 GHz. Now let's check the captured Wi-Fi frames. Surprise, surprise, surprise. See the empty window for 2.4 GHz and 5 GHz? Nothing was captured from the iPad. For 6 GHz, as expected, you see a whole bunch of successful communications, right? Let's investigate what happened in 2.4 GHz and 5 GHz. If for these 2 bands there were no communications, how the iPad even knew the existence of 6 GHz? Let me change the filters to the access point instead of iPad. Okay, the access point was really busy, but it's just it didn't have any direct communication with the iPad. For example, in 2.4 GHz, the access point was busy broadcasting the beacon frames for this SSID. And for 5 GHz, similar situation. Then if the iPad even didn't try to send out probe request for this SSID, how the iPad even knew the existence of 6 GHz, right? If you check the 6 GHz session, you don't see probe request and the probe response. So basically, the iPad directly authenticated to the access point. So let's click a random beacon frame, expand the wireless management section. Here, you see a familiar section called reduced neighbor report. If you expand it, you will see the exact same information as we saw before, but during that time, we only checked the probe response. So the reduced neighbor report was part of the probe response, right? In fact, it was also in the beacon frame itself. So to put it the other way, the iPad even didn't need to ask for the information. The information was already automatically broadcasted from the access point. You know what? Even though the iPad way is different than Android and Windows, I have to say it seems to be smarter because it saved the unnecessary probe request and the probe response process. The information was already in the beacon frame. What happened was the iPad got the 6 GHz BSSID information and then directly communicated with the access point in 6 GHz. It completely skipped 2.4 GHz and 5 GHz. Okay, so now it seems to be clear, but still it doesn't answer our original question. Where is the band steering settings effect? Let's do one more test. Let me change back the band steering setting for this AP. Disable band steering. Then let me use iPad again. Let's see when we don't have the band steering enabled, whether we have the same result. On iPad, let me repeat the same steps. I will speed it up. For all 3 times, they connected to 6 GHz. Unfortunately, we have almost the same result. See the 2 blank windows for 2.4 GHz and 5 GHz. The only difference I can observe is for 6 GHz, there were 2 probe requests from iPad. Apparently, there were no probe responses, but iPad went ahead, connected to 6 GHz anyway, because it had the information from the reduced neighbor report, right? After the back and forth testing using 3 different devices for the per AP band steering settings, I'm completely lost. I haven't really observed any effect from the band steering setting on AP level. What I mentioned in the diagram apparently is not the way how UniFi implemented. Maybe this feature was obsolete. It's just Ubiquiti forgot to hide the setting from the UI, or I'm totally wrong in the testing setup. If you know the answer, let me know in comments. Now let's proceed with the SSID level band steering testing. Okay, let's move on to the band steering testing when it's done on the SSID level. I already made sure on the AP level the band steering is disabled, and on the SSID level it's also disabled. I already moved the PC, the Windows machine, away from the AP, so you can tell from the RSSI they are acceptable but not super good. Then let me try to connect to the SSID without the band steering enabled. Let's see what will happen. Okay, it's connected to 6G. Disconnect. 6G. Disconnect. 6G. Apparently, without changing anything, we cannot really use it to test the band steering, because when band steering is even disabled every single time, it's connected to 6G. So let me manipulate the signal strength so that we make sure the 2.4 GHz has highest signal strength. I lowered the transmit power for 6G and 5G to low, and I keep the 2.4 GHz to high. Apply changes. Now you can tell from the Wi-Fi info view the signal strength for 5 GHz and 6 GHz, they are both very low. Keep in mind, now the band steering setting is still not enabled. Let me try to connect to the same SSID to see whether it will choose 2.4 GHz. This time it initially chose the 2.4 GHz. Okay, now we are ready to enable band steering on the SSID level. Go to the setting for the SSID, enable the band steering. I have enabled the 3 sniffers. Try to connect to the same SSID. No change, it still connect to 2.4 GHz. Connect 2.4 GHz. Last try 2.4 GHz. So even though we enabled band steering, it seems at least for Windows there's no effect at all. But let's still try to read the captured frames. Okay, this is what we see from the 3 sessions. Let's check 2.4 GHz. Yeah, it sent out the probe request. UniFi AP responded. If we check the details, you should be able to find the familiar reduced neighbor report, and it should have the 6 GHz BSSID information. Yes, it does. Nothing's changed. You should be able to see the authentication and successful 4-way handshakes. The Windows machine connect to 2.4 GHz instead of 5G or 6G. And for 5G sessions, yeah, the normal probe request and response, but it never tried to connect to 5 GHz. I believe it's due to the weak signal strength. And when it comes to 6 GHz, as expected, there's no any response from AP back to the Windows because the AP never asked for the particular SSID, but even if it asked, the AP wouldn't respond, just like we observed in previous testing, right? So everything's normal. The only problem is band steering doesn't take any effect to Windows, at least in this particular testing. So that's disappointing. Remember in previous video when I talked about this scenario, I said a possible implementation might be AP will send BSS transition to the Wi-Fi client, try to steer it to other band, right? Let's see whether AP sent anything like that to Windows. The Windows machine connected to 2.4 GHz. So let me try to search for BSS transition packet. So basically, if there was a communication about BSS transition, there should be response and request from the AP and the Wi-Fi client. So I should be able to find some frames with action code equals to a value greater than 1. We don't need to care about what's the exact action code because you can see there's no any frame related to this particular Windows machine and the AP. So nothing's happened. There's no BSS transition frames at all. Our theory didn't apply to this particular testing. The AP never sent BSS transition frames to Windows. The Windows didn't transit to other band. Basically, this setting is a failure for this particular Windows. I believe that's why here in the UniFi network controller, it says it can only steer the compatible Wi-Fi device to 5 GHz. It seems this Windows machine is not compatible. That's the only explanation I can give at this moment. Okay, but let's switch to another Wi-Fi device. Let's try iPad. Let's first test it without band steering enabled. Okay, initially connected to 2.4 GHz, but then automatically switched to 6 GHz, even though the signal strength was very bad. Try again. Okay, initially 2.4 GHz, then automatically change to 5 GHz. Then try again. Okay, 2.4 GHz. Then jump to 5 GHz. Then just stay there. Yeah, it did change the band automatically, even though we didn't have the band steering enabled. As you can see, I already enabled the 3 sniffers, and in UniFi network controller, I also enabled band steering on SSID level. Let's try iPad again. On iPad, connect. Okay, this time automatically is connected to 6G. Disconnect, connect again. Okay, 2.4 GHz. Then automatically switch to 6G. Try again. Okay, 2.4 GHz. Then change to 6G. We can ignore the first time it's connected to 6G. Let's examine the captured frames to see what happened. Okay, I opened the 3 captured files, scrolled to almost the same point of time. At that time, iPad was connected to 2.4 GHz. This particular frame was the last one sent to the AP. Then for a long time, you can see there's no activity between the iPad and the access point in 2.4 GHz at all. And then starting from this time, the iPad sent out the probe request in 6 GHz. And then it started the authentication successfully reassociated to 6 GHz. Apparently something happened at this time so that the iPad switched from 2.4 GHz to 6 GHz, right? But from the 2.4 GHz captured file, I don't see any disassociation or deauthentication frames. Neither iPad sent anything like that to AP, nor AP sent anything to iPad. So somehow the iPad simply discarded the connection in 2.4 GHz band and then switch to 6 GHz. From the captured files, I don't have any clue what really happened. Let me still search if we have any BSS transition or neighborhood report frames in the 2.4 GHz. So let's still use the query filter on the action code. Even though there were a lot, none of them was between the iPad and our access point. I don't have explanation about why the iPad even switched band. Let me try another way. Let me check the backend system log for the UniFi access point. In this terminal, I already SSH'd into the access point. Let me run this command to show the message log files. From the iPad, let's connect to SSID. Yes, it's connected to 2.4 GHz. Then jump to 6 GHz. Okay, something's captured in backend. Let's stop the Wi-Fi, then check the system logs. Let's check what's being displayed in the backend message logs. Let's start from this one. There was an event and it's about this interface. By the way, ATH0 is about 2.4 GHz. Later you will see ATH3 or ATH5. 5 is for 6 GHz. This event is about the 2.4 GHz and it's about this MAC address for the iPad. What's the event? The station join the AP. See the association message and then the four-way handshakes. Authentication was successful. Here it comes the dumped event message. It says for this particular MAC address, for this particular 2.4 GHz interface, it was successful. This is for our iPad initially connected to 2.4 GHz. And then see what happened. Here comes a new event. The exact same iPad joined ATH5, which is for 6 GHz. And similar information for the handshakes, and then the join was successful. I don't see any strange thing happened between these two events. I still don't see any explanation why the iPad switched from a strong signal 2.4 GHz to the weak signal 6 GHz. I don't see whether it's AP forced it to do that or the iPad took initiative to make the switch. And then later to event message for the 2.4 GHz, there was a fix up event. That's about the iPad leaving the access point. And then here there's another message. It's a soft failure message, and it's about the iPad and the 6 GHz. I cannot find any UniFi documentation explaining what's soft failure, what's fix up. Maybe they are related to the root cause for why the iPad changed channel, but at least I don't really have any explanation what these two events really means. Yeah, so basically that's disappointing information we can see from the backend message. Okay, so after this very long video, we tried 3 different devices, we tried different band steering configuration changes, and we saw strange results again and again, but for none of them, we got expected results. I would say this video is a complete failure because it didn't provide any support to my first video, and there were a lot of unanswered questions. But I still decide to post this video. Just hope if you have any insights, please let me know in the comments. Let's try to resolve the puzzle for Ubiquiti's UniFi band steering setting on UniFi network controller. Okay? Thanks for watching.